You know that feeling when you're maybe 5 minutes into a run?
Oh yeah, the heavy legs.
Exactly, the heavy legs. You're debating quitting, and then that one track hits on your playlist.
Right, the driving bass line.
Driving bass line, and suddenly you aren't just running anymore, you're flying.
The classic Rocky moment.
Right. We usually just think of that as, motivation. We think music is essentially emotional wallpaper, just background noise to make life a little prettier.
But if you look at the research stack we have today, that might be a complete misunderstanding of what is actually happening biologically.
Yeah, because we're doing a deep dive today into the hidden mechanics of sound, rhythm, and even nonverbal cues. And looking at our sources, this is a lot more than just wallpaper.
Oh, absolutely. We've pulled studies from the University of Vienna, evolutionary algorithms from the Proceedings of the National Academy of Sciences, clinical reviews on digital drugs.
Which sounds wild, by the way.
It does. And practical research on body language. The mission here is to decode how these external rhythms, whether it's a complex piano piece, a binaural beat, or just the silent rhythm of a smile, how they actively alter your perception, your performance, and even who you're attracted to.
So we are essentially talking about how you can hack your own neurology, and potentially the neurology of the people around you.
That's the core of it, yeah.
Let's start with what is probably the highest stakes scenario for most people. The date.
The biology of attraction.
Yes. We have this study from Marin and colleagues over at the University of Vienna, and they link music directly to sexual attraction. But they don't start with modern psychology, they go straight back to Charles Darwin.
Right, because Darwin had this theory back in 1871 that music wasn't originally created for art, it was for courtship. He viewed human music as the auditory version of a peacock's tail.
And the peacock tail is, that's the classic example of costly signaling in evolution, right?
Exactly. It serves absolutely no survival purpose. If anything, it makes the bird slower and much easier for a predator to eat.
But it proves he's healthy enough to survive despite carrying it around.
That's the theory. And Darwin thought music functioned the exact same way. If you think about singing a really complex aria or playing a highly technical piano solo, that requires fine motor skills.
Right.
It requires cognitive processing, emotional depth. It's a signal that says, I have excellent genes, and I have the surplus energy to be this loud and this precise.
So the Vienna researchers wanted to see if this evolutionary wire is still active in modern humans.
Yes.
And the setup for this experiment is fascinating. They took a group of men and women, played them 19th century piano solos, and then simply asked them to rate photos of faces.
Right, but the key variable here was the arousal level of the music.
And we should clarify, arousal in a psychological sense, not necessarily sexual.
Right, arousal just means intensity. How much does it wake up your nervous system?
Yeah.
So they use highly complex, high-intensity music for one group and simple, low-intensity tracks for another. Then they show the participants a completely neutral, static expression and basically asked, would you date this person?
And the results were incredibly specific. It did not work on everyone.
No, there was a massive gender split. For the men in the study, the music made almost no difference at all to how they rated the women.
Wow.
But for the women, listening to the complex, high-arousal music made the male faces significantly more attractive. They rated them much higher for dating desirability.
So the woman is listening to this intense piano music, her heart rate goes up, her brain lights up, she looks at the photo and suddenly thinks, he's the one.
Yeah, it's a phenomenon called the misattribution of arousal.
Misattribution of arousal.
Right. The human brain is actually terrible at identifying where excitement comes from. The music creates this physiological spike. You get alertness, a rush of dopamine. But the brain desperately looks for a physical cause in the environment.
So it sees the guy in the photo and just tags him as the source of the excitement.
Exactly. It's a literal brain hack. You are taking the energy of the song and pasting it onto the person in front of you.
But why the massive gender gap? Why didn't the men fall for the same trick?
Well, the researchers speculate that it goes back to that evolutionary priming Darwin talked about. If music evolved primarily as a male courtship display, women's brains might be evolutionarily tuned to listen for that auditory peacock tail.
And the men?
Men might rely much more heavily on visual cues to assess mating fitness. The auditory channel just isn't their primary mating radar, so the music doesn't override their visual assessment.
Okay, so if you're a guy setting up a first date, the background playlist isn't just nice to have. It's actually doing heavy lifting for your perceived attractiveness.
If it's complex, yes.
Right, but then we have this other study, the Japanese Gokhan study by Shigeno and colleagues from the journal RMRS, and it kind of says, don't overthink the genre.
Yeah, this one is much more practical for everyday life. Erokhane is a type of group blind date in Japan, so they tested an actual conversational setting.
Real-world application.
Exactly. And they tested silence against background music. Pop, rock, classical, rap, it didn't really matter. In that setting, any music improved the participants' likability and desire to date compared to pure silence.
Is that just because silence is the enemy of chemistry?
Basically, yes.
Yeah.
Silence creates social tension. It makes you hyper-aware of yourself and every awkward pause. Music fills that void. It creates a shared mood.
Shared rhythm.
Right. And if the music is pleasant, you associate that pleasantness with the people you're with. It's still a form of misattribution. It's just a broader, friendlier version than the complex piano trick.
So the takeaway for the listener so far in a lab, complex music hacks attraction for women. But in the real world, just having a beat going saves everyone from awkwardness.
That is the safe bet.
I want to bridge this idea of rhythm to something slightly different, because we usually think of rhythm purely as sound, right? Beats per minute. But looking at the sources, there is a visual rhythm to how we interact.
Yes, the nonverbal cues.
Exactly. We have this breakdown from Dr. Ronald Riggio on body language and dating psychology, and he argues that physical cues spike arousal just like music does.
You can think of body language as a silent drum beat. It regulates the entire interaction. If the beat is off, the interaction completely fails.
What's an example of that?
The classic one is the eyebrow flash.
Oh, this is the one you absolutely cannot unsee once you learn about it.
It's primal. When you see someone you recognize or someone you want to signal safety to, you naturally flash your eyebrows up for about a fifth of a second.
It's so fast.
Super fast. It happens before you even speak a word. It is basically the visual downbeat of a conversation. It says, I see you, and I am not a threat.
And what happens if you miss that beat? Like if you walk up to someone with a completely frozen face?
The other person's lizard brain instantly pulls the emergency brake
Wow.
because a lack of an eyebrow flash signals either a threat or a dominance play. It breaks the rhythm of connection immediately. You haven't just been impolite, you have actively failed a biological safety check.
Riggio also talks about the smile. He differentiates between a fake smile and a Duchenne smile. And it seems like it comes right back down to complexity, just like the Vienna music study.
It does. A fake smile is biologically very simple. It's just the corners of the mouth going up. It's called the Pan Am smile.
Right, the flight attendant smile.
Exactly. But a Duchenne smile, a genuine one, engages the orbicularis oculi muscle.
Which means
It crinkles the eyes. It gives you crow's feet. It is a much more complex motor signal, and it's actually very hard to fake. That complexity tells the other person's brain this enjoyment is authentic.
we are surprisingly good at spotting the difference between the simple fake and the complex real.
We have to be, for survival.
Then you have the concept of personal space, the bubble. And this connects directly back to the arousal misattribution we started with.
It definitely does. Stepping into someone's personal space triggers an immediate physiological spike. Your heart rate jumps, you get a little hit of adrenaline.
Because your perimeter has been breached.
Right. Now, if you do that at the right moment, say, when the shared rhythm is good, the conversation is flowing, maybe there's music playing, that arousal adds to the stack. The brain interprets that spike and thinks, oh, this is intimacy.
And there's also the Midas touch effect mentioned in the research.
Yes, where a very light, appropriate touch, like a waitress briefly touching a customer's arm, leads to significantly higher tips. It's a micro spike in arousal that creates a bond.
But if you step into the bubble at the wrong moment, without that established rhythm,
Then the brain interprets that exact same arousal spike as a threat. It is all about timing the input. You're literally managing the other person's arousal levels visually and spatially, the same way a DJ manages a room's energy audibly.
we are really painting a picture of humans as these biological machines that are pretty easy to program if you just know the right inputs.
It's a little unsettling when you put it that way.
It is, which makes this the perfect time to transition to the most controversial part of our research stack, digital drugs.
Ah, yes. Or, if we're using the scientific term, auditory beat stimulation, also known as binaural beats.
Right, so the promise online, if you go on YouTube or whatever, is that you can download an audio file, put on your headphones, and basically get the same effect as a glass of wine or a dose of focus medication. Which, frankly, sounds like pure snake oil.
The getting high part is largely marketing hype, yes.
Yeah.
But the underlying mechanism is based on real physics. It relies on a very specific auditory illusion.
How does it work?
So if I play a pure tone of 440 hertz in your left ear, and a slightly different tone, say 400 hertz in your right ear, Your brain actually cannot reconcile the difference between the two sides.
So it just panics.
No, it creates a phantom tone to bridge the gap. It pulses at the exact mathematical difference between the two tones.
So 440 minus 400.
Exactly. It creates a 40 hertz pulse. You hear this wah-wah-wah beat that is not actually playing through the speakers. It is constructed entirely inside your auditory cortex.
That is wild. And the theory behind why this is a visual drug is entrainment, right?
Yes, the frequency following response.
Meaning your brain waves will essentially march in step with that phantom beat.
That's the idea. Your brain operates at different frequencies depending on your state. Beta waves for focus, delta waves for deep sleep. The theory is if you want to focus, you play a binaural beat that creates a phantom beta frequency. You're trying to drag your brain state to match the sound.
We have a massive literature review here by Erokhane and colleagues that actually looked at the clinical data across multiple studies. Do these things actually work?
The data is definitely mixed, but there are some genuine bright spots. They found evidence that targeting beta frequencies can actually sharpen working memory and long-term recall.
And what about sleep?
Targeting delta frequencies did show promise for deepening sleep and reducing daytime sleepiness.
I noticed they also spent time looking at anxiety, specifically preoperative anxiety.
Yes, that was one of the strongest findings in the review. Using these specific auditory beats before surgery actually lowered anxiety levels and even pain perception in patients, for example, during cystoscopy procedures.
Wow.
So as a clinical tool for chilling out the nervous system, there is definitely something real there.
But you still can't just download a hallucination.
No, absolutely not. And we have to impartially point out that some studies in the review showed absolutely zero effect. Sometimes it even negatively impacted cognitive performance.
So it's not a magic bullet?
No, individual responses vary wildly. But if you are looking for a focus hack or a way to wind down, it's a very low-risk experiment to try on yourself. It's essentially just hacking the brain's natural tendency to synchronize with its environment.
Speaking of hacks, let's look at one combination that seems to be universally accepted. Music and exercise.
The ultimate pairing.
Right. But this study we pulled by Yang and colleagues had a twist I really didn't expect. It wasn't just a simple case of music makes you run faster.
No, they looked deeply into what we can call the depression nuance. They took a group of college students and put them on a treadmill, but they divided them into two groups, some with totally healthy moods and some with minimal depressive symptoms.
And minimal depressive symptoms just means the blahs, right? We aren't talking about severe clinical depression, just low motivation, feeling a bit down.
Exactly, that mental fog where everything just feels a little harder than it should. Now, we already know that music generally lowers the rate of perceived exertion.
Right, it distracts your brain from the burning in your lungs and your legs.
Right, that effect is pretty universal. RBE goes down. But the cognitive effect, what happened to their attention after the workout, was drastically different between the two groups.
Break that down for us.
For the students with the blahs, the minimal depression group, combining rhythmic music with aerobic exercise, was essentially magic. It created a powerful positivity bias.
Positivity bias meaning what?
Meaning that after the multimodal workout music plus exercise, their brains were measurably faster at spotting positive images and reacting to them. The combination completely jump-started their mood and attention.
But for the students who were already in a healthy mood state?
For them, the music was actually just noise. Yes. For the completely healthy group, exercise alone in silence was the most effective way to boost their attention. Adding the music actually distracted them from the mental clarity of the run.
That is a huge takeaway. Because we just assume more input is always better.
Right.
So if you are feeling low, you need that multimodal stimulation. You need the dopamine from the beat combined with the endorphins from the sweat.
Yes, to overcome the deficit.
But if you are already in a high-performance, healthy state, your curated playlist might actually be holding you back cognitively. You might just need the silence.
It's all about matching the stimulus to your current deficit. When your brain is firing on all cylinders, extra input is just clutter. But when your brain is struggling, that extra auditory input acts like jumper cables for your mood.
I love that. Jumper cables for the brain. I want to zoom out for our final segment. We have talked a lot about how we use music to hack our own biology, but where is music itself actually going?
The macro view.
Exactly. We have this fascinating evolutionary algorithm study from the journal PNAS called Darwin Genes by McCallum and Adami.
This is such a brilliant experiment. They basically built a survival of the fittest engine, but for songs instead of animals.
They let the internet breed music.
That is exactly what they did. They started with short loops of completely random noise, just static and beeps. Then thousands of human listeners rated them.
Okay.
The loops that people liked, the ones with a hint of a beat or a chord, were allowed to breed. The computer mathematically combined them, adding tiny random mutations to create the next generation of loops.
And the ones people hated.
They were deleted. Evolutionary dead ends.
And initially, this worked perfectly, right? The music evolved from pure noise into actual recognizable structure.
Very rapidly. For the first 600 generations, the quality of the audio skyrocketed. It sounded better, more complex, more musical. But then, it hit a wall.
The plateau.
The plateau. The music completely stopped improving. It didn't get bad, but it just stayed exactly the same. It churned out these generic, perfectly pleasing loops forever.
But why? If evolution is an optimization engine, shouldn't it eventually create a masterpiece? Shouldn't Darwin Tunes eventually write a Mozart symphony?
You would think so.
Yeah.
But this is where we hit a biological and computational concept called synergistic emphasis.
Synergistic episthosis. That is quite a mouthful. Break that down for us.
Think of it like a Jenga tower. When the tower is just a few blocks high, when the system is very simple, you can move pieces around, mutate things, and the tower won't fall. That is the early stage of the Darwin Tunes music.
It's easy to improve because there's no complex structure to ruin.
Exactly. But as the music gets complex, you have a bass line interlocking with a melody, which is interlocking with a specific harmony. It becomes like a 50-story Jenga tower.
It becomes incredibly fragile.
Very fragile. The parts rely on each other too much. At that high level of complexity, any random mutation, any attempt to change a trait to make it better breaks the synergy. You are 99% likely to knock the entire tower over. The structure is just too interconnected to survive random tinkering.
So the evolution just stops taking risks.
Exactly. It settles for good enough.
Yeah.
It finds an evolutionary peak where the music is pleasant and it stays there forever. Because the cost of trying to be great via random change is a total collapse back into noise.
I have to say, that sounds uncomfortably like the current state of pop culture.
It really does, doesn't it?
We're seeing the exact same movie franchises, the exact same four-chord pop progressions, just recycled hooks everywhere.
It is the epistatic conundrum playing out in real life. To get to a higher evolutionary peak, to discover something truly new and breathtaking, you might have to descend into the valley of noise first.
You have to break the current structure.
Right. But biological systems, and seemingly cultural ones too, they hate doing that. They naturally stick to the local peak of what is pleasant and safe.
So we are essentially trapped in a loop of our own making because we are too afraid to listen to noise for a little while.
That's the danger of hyper-optimization. Efficiency eventually kills innovation. We optimize ourselves right into a rut.
Man, that is a lot to process. So here is the synthesis for you, the listener. You are constantly navigating a world of hidden rhythms.
Yes, internal and external.
Right. So, curate your environment. Use complex music to hack attraction on a date, but know that you are utilizing a misattribution trick.
And use the eyebrow flash to signal safety before you even speak.
Try out binaural beats to hack your focus or lower your anxiety.
But also know when to turn the inputs off. If you are already thriving and healthy, pure silence might actually be the best playlist you have.
Absolutely. And I want to leave you with that final thought on the Darwin Tunes plateau. Look at your own habits. Are you stuck on a local peak? Are you listening to the same things, doing the exact same routines, just because it's good enough and you're afraid to break the structure?
That's a great question.
If the Darwin Tunes experiment showed us anything, it's that music and maybe human growth stops evolving when it becomes too complex to change. Have we reached a biological plateau with our own music? Are we just recycling the same pleasurable loops because our brains can no longer process a better version?
Sometimes a little discomfort and a little noise is the only way to upgrade the system.
Well said. Thanks for diving deep into the rhythm with us. We'll see you on the next one.